Awesome. So hi everyone, hope you can all see my screen. This is Multimodal Weekly, a virtual webinar series hosted by the team at TwelveLabs. This is an initiative that we've been working on over the past 3 years or so on a weekly basis, community effort to cover various topics that is exciting and relevant in the world of multimodal AI and foundation models. A lot of researchers coming in, talking about different projects and papers that they're working on. Occasionally, we have customers and partners sharing different applications they build in various verticals. Community members, developers talking about different video and multimodal projects that they build on top of our API and platforms. And of course, internal speakers sharing best practices on how to use the technology. These are some samples of some of the recent session over the past month or so. We got people building in sport broadcasting, interview coaching, real estate, um, on-device PC building, misinformation detection, etc. Um, for today's session, we have two very exciting presentation, and both of them are built during the one of the hackathon that we have co-sponsor about a month ago at UC Santa Barbara. The first group is going to be Aidan Dawley and Omar Farag, who will present the project called Memory Vault, which is a private shared media vault for friend and family groups. You can upload photos and video into a single vault, get AI tags and caption for each memory, normalize messy tags into clean canonical categories, and let you browse by category and quickly jump to what you're looking for. It's very powerful demonstration of our embedding model. So excited to see how they've been using our technology to do that. Then for the second half of the webinar, we have Bradley Show and Madhav Dantula, who will present their project called T-Ether, which transform long educational videos into a binge-worthy macro lectures. Users can upload a 15-minute long lectures, get back a series of 30 to 60 seconds TikTok reel style clips, each one focused on a single concept, complete with hooks, animated caption, and smart visual editing. So yeah, this is another very exciting use case of transforming long form footage into short form highlights that we've seen very, very popular within our media and sports customers. So excited to see how, Bradley and Madam has been building this within 24 hours. Yeah, so since a pretty small group, feel free to send your question on Zoom chat, or you can, unmute and ask the question live after all the speaker has finished. So with that, I will stop sharing my screen. And then, yeah, Aidan and Omar, you guys want to go ahead and get started?
Yeah, sure thing. Thank you. Let me share my screen 1 second. All right. Hello, everyone. Good morning, and thanks for giving us a chance to speak on our Memory Vault project. So, Memory Vault is a project that uses 12 Labs to bring you the perfect app for reliving memories with your friends. So, I wanted to start off our presentation with a little story. So, last summer, I went on a road trip to Yosemite with my friends, and we had a chance to stop at all sorts of cities and landmarks as we drove our way up California. So, we decided to create a shared media folder on Apple. Anytime one of us would take a picture or video, we would upload our photo or video so that we could all have access to it and relive our memories together. This worked great for a while, but towards the end of the trip, we had 443 photos and videos. So, like now, when we look back on the trip, it can be hard to find memories in specific videos. My friends could say, "Remember how nice it was when we saw those deer in Sequoia?" And I would find myself having to swipe through about 500 different videos and photos just to find our 2 or 3 photos of the deer. So this is where Memory Vault comes in. It serves as a middleman between the unorganized Media Vault and a group of viewers. With the 12 Labs and Gemini models, we found a way to break media content down into asset tags that could be organized in a fun and exciting way. So now when we look back at a folder of media, it can be so much more than just a repository. It's a montage of your best moments and your great memories with friends. Omer and I have prepared a live demo for you at the end that we'll be demonstrating. But for now, I'm going to walk you through some of our design decisions and how our software accomplishes its organization. So, what issues are there to even face when developing a project like this? At first, this kind of software sounds like a slam dunk case. we call the TwelveLabs API and then we just create video tags and we can just check if the video tags equal each other and then put them into a category that a viewer can view. The issue that arises in this is that there's always going to be a small variation in a model when you provide it with separate videos. You may have cases where you get syntactically similar categories like dance and dancing, or you may get similar tags that don't mean the same thing, or that do mean the same thing but don't look the same, like dancing and grooving. Um, and another issue arises in the fact that we're using two different models. We use Gemini for images and 12 Labs for videos, so there might be some variation in the tags that we're developing between these two photos and videos. And without a proper system to process our tags, we would just end up with a bunch of categories that essentially mean the same thing and provide no extra enjoyment or organizational value to our users. To solve this, we introduced our data pipeline that takes a collection of tags from multiple sources and forms a coherent and enjoyable set of categories that aren't repeats of each other. So getting down to how our program actually works, we start with the user uploading an image or a video to their media vault. Each time the video or image is uploaded, we take time to process the tags and place the tags on the image or a video as soon as it enters the vault. So when we upload the image or video, we select our model, Gemini for images and 12 Labs for video. And once the media piece is processed, we take the tags into our data pipeline to organize and normalize them. So we go through a multi-step process to ensure that we're efficiently choosing the best categories to create or adapt. Every time a tag is created, we decide whether the tag should be mapped to a current tag that already exists or should be allowed to create a whole new category of tags. To start our process, we normalize our text. We remove spaces, punctuation, and capitalization to make sure that if there is a match with other tags, it's not held back by a weird syntax. We then run a syntax search across our tags. And if we, for example, if we have dance as a category already and the model generates the word dances, it would immediately map dances to dance just because they're so syntactically similar. But oftentimes we don't have that match. So if we cannot find a match from format similarity, we need to check if we have a meaningful match by word meanings. The example I used earlier was groove and dance. They have the same meaning, but they don't look the same at all. So we use a library from NumPy called sentence transformers. Sentence transformers converts text into dense numerical vectors called embeddings that capture semantic meaning. By placing similar meanings close together in the vector space, you can compare these texts using cosine similarity so that instead of matching exact words, the model measures how conceptually similar two pieces of text are based on those embeddings. We store this new vector value in a cache, and each time a new word comes in, we can compare our new vectors against the cache to see if we have an already very close existing category. And if that existing category does exist, we're going to map the vector to that category. And if there's no close vector match, then we're going to create a whole new category to compare our future tags to. So now I'm going to pass it off to Omar, and he's going to show you a live demo and talk a little bit more about our project.
Let me share my screen real quick. Hey everyone, I'm Omar, and I'm going to be demoing the Memory Vault project. So there is a major problem, like Aidan said, is that when you have so many photos and so many videos, it's hard to organize everything and find what you want. And this is where Memory Vault comes into play, powered by the 12Labs API. So here's the three things that we target. We target the auto tag organization. So each photo, each video, you'll have a tag and it'll be shown with the video and the photo, each tag that the 12Labs API generated. And the second use is that it is a fun way to see all of the perspectives of each person uploading their video and photo into one Google Drive-like media. And lastly, we made this so that it's more of a personal sort of social media like Instagram, but even closer where you're uploading each photo and video. And the way that we set it up is you'll have your title and the photo, and you will see each tag that was generated by the TwelveLabs API. So some examples here would be dogs. You'll see dog, pet, concert would be concert, music, and even things like nature with sunsets. So let's dive into a demo to see how you would actually use this workflow. As you can see, it's sort of like Google Drive where you have each vault. And each vault, you could use it for different events, such as personal, or in this case, school and work. So for this demo, we're going to be using personal. And for the sake of the demo, we've already uploaded some materials of Jim and Pam's wedding from the office. And here we'll click through and see some of the different videos and photos that we've uploaded. See, we have a guy dancing, and you can click and see some of the tags such as dance and guy. Fun moves. And as you make your way down the page, you'll be greeted with Browse My Tag, which is essentially the most common tag that you find across all of the media that's been uploaded. So in this case, a lot of wedding photos have been uploaded, and it would be categorized into wedding, as you can see by the 5 pieces of media that we have here. So you can click on it and see some of the tags that the 12Labs Pegasus API generated, such as wedding, bride, groom, and kiss, and some other adjacent tags. But now we want to see how would you add some more media? What would that process be like? And I'll show you. So as you scroll to the bottom, you can go to add a new memory. So let's add one. And I prepared a video that we can use. So let me get that real quick. And it is a 5-second clip of someone dancing, which I'll demonstrate. So let's give this a title, Dancing Down the Aisle. And we'll add it to our vault. So while it's uploading, I'll explain what's going on. So it's calling to the 12Labs Pegasus model, and we specifically chose this model because of the unique tag generation that is able to use to analyze the photos, I mean videos, so that it can generate the specific tags for organizational purposes. As you can see, it's taken a little bit, and we're working on optimizing the algorithm so that it doesn't take so long to upload each photo, but we are working on it. So after you give it a minute or two, as you can see, when you scroll back up, you'll have the video right here in wedding. Tap on it and see some of the special tag that was generated by the 12Labs Pegasus model, which is real neat. Happy day. And that's all we have to show for now. So thank you so much for having us and allowing us to show our product.
Awesome. Is that the end of the presentation? Do you have any more slide?
Yes, that is the end of our presentation.
Great. Awesome. I think it's a very excellent demonstration of like media discovery use cases. I think, and I love the UI UX design that you put together to make that front end like looking nice as well. And demonstrate like the capabilities of Pegasus for AI generated tasks, right? Great. So I saw that there's a couple of questions on the Zoom. If you guys want to address them one by one, Aidan and Omar, just unmute and answer the question one by one. Let's do that until maybe like in the next 5 minutes so that the second group can also go as well.
Okay, so I saw where the videos and images stored and processed. So right now we're working on deploying our app. It's a little bit hard because we're just students and we don't really have like a plan to sell anything. So as you can imagine, like it'd be expensive to like get a lot of server space and stuff for uploading a lot of videos on the cloud. So right now the images and videos are just stored locally on your computer. And the tags are also just stored locally in your program. But I also saw where is it all processed? For our process right now, we're calling the API call to the 12 Labs Pegasus model and just importing those tags. So we get those tags from the model and then we just store it locally on like our images. And so the max length of the video would also be just what the max length of the actual Pegasus model accepts for image input. And of course, there would be like there is a max length, but maybe we wouldn't want to use all of our um, API limits on a super large video. It's more designed for like those small moments and memories. Like if you have like hundreds of smaller images and hundreds of smaller videos.
Mhm.
And we don't use BitTorrent right now, again, because we haven't deployed anything. So we're working on that. We'll probably take that into consideration as a good idea as well. And then I also saw the last question. Can I search a library-wide term? Right now, we can't really do, unless you titled your image a library-wide term, we would have to use another part of the model to create like some sort of either like some sort of embedding or some sort of sentence about the video, because right now we're just generating tags. So you would only be able to search by tag as of right now. Uh,
And about if we plan to add Memory Vault as a part feature of default photo gallery instead of building a separate app.
Right now, it looks like we're gonna do it as a separate app. I think there is like an actual room for like recently there was that one app that went popular a few years ago called Be Real, the social media app, and there's actually like a real craving for the smaller, more personable social media apps where you like can feel free to upload like more personal images and more personal moments rather than having like your best look all the time on everything. So like this product more functions as a way for like in our example, like if you went to Jim and Pam's wedding, then Jim and Pam might make a media vault and invite everyone to do it to upload to the media vault, and then they could all upload their images from the event. And then now whenever someone wants to look back on this event, it's like, oh, remember when we went to Jim and Pam's wedding? They can go to the app, open the media vault, and they have this whole organized section of fun memories. It's like, oh, and then they scroll down to the dance section and they could see, all their memories from when everyone was dancing or yeah. So it's more about creating that social media experience as well. Like we want to add the functionality of like, oh, you can like a photo and um add like comments on a photo and that kind of stuff. I think that would be beneficial for us as well.
Awesome. I know that I did a lot of these for like trips, right? Everyone like keeps sharing their Google Drive or their iPhone Photos app, so people can add stuff in it. So this could be like great example of keeping memories from these trips with, among like small group of friends. I think there's two more questions. You want to address them?
Okay. Um Honestly, do I plan to agentify this for OpenClaw? I've been seeing a lot about OpenClaw. I'm kind of like I'm skeptical personally. I'm part of like a security team at a company, so like I'm very security minded first, and I think giving it such personal access to these photos might be a little bit much for OpenClaw just because it's so new, open source. And I don't know, I saw like there was like 200 vulnerabilities on the day of release and that kind of thing, so I'm not the biggest fan of OpenClaw, but maybe if the technology progresses, we would be totally open to that type of thing. And how would we differentiate this from Google Drive's new functionality that allows you to search in your videos? So what differentiates this as from Google Drive is that it's not just a way for us to search videos because I think even Apple has like small functionality. Like if I search a license plate, it would show me like my license plate that I took a picture of like a few years ago. But this is more like the organizational part gives us like a fun way to experience our memories. And it's more oriented about that social media mindset rather than just searching for a moment. Because like when you open the UI, it's not just like, oh, I need to find this video immediately, so let me search for it. It might be like, oh, let me scroll through the videos and see this category and see, what has everyone else posted? Or if there's a big event, then everyone might have posted a different angle of some crazy fight or some crazy like dance or something. And now you can scroll through those and they're all organized into the same type of category.
Yep. Yeah, I say this would be a great feature for like events company, right? Think about like, I don't know, let's say Eventbrite have like a video features, for example, then you can like categorize and search from like past testimonials, like video testimonials of people who attend this in the past, right? Instead of just reading the text that describe the event. I think that'd be interesting. Yep. Great. Any other question from the audience? I think we have addressed most of them, all of them actually.
Yeah, thank you guys for those questions. It was a lot of fun to use the 12 Labs model to make this great opportunity.
Absolutely. Thank you very much.
All right, sweet. Thanks, Aidan and Omar. I know right now it's still like a local deployment, but if you make it publicly available, um, for like the public user to upload it, could love to like share that without developer community as well, so that you can see how people like using it and then contribute to it, right? Overall, I think it's a great front end, simple but effective. All right. So Bradley and Madhav, you guys wanna unmute and share your screen for your presentation?
Yeah, for sure.
Do you know how to share your screen?
Oh, sorry. It won't allow me. I need to. Yeah, I think I recently just updated it, so I have to quit and reopen. Okay, sorry, just give me like 5 seconds. And it's making me
Yeah.
give it access again to share my screen just for Zoom. Sorry about that.
Yeah. Okay. Madhav, do you think you can share your screen? Or do you guys wanna?
Yeah, for sure. Let me just start up on that real quick.
Yeah, sorry about that.
Oh, okay, never mind.
Okay, I can see it.
Everything look good?
Yep.
All right, great. So yeah, here we start. Hi everyone, I'm Bradley and I'm working with, we worked on Tether. Basically, this is a sort of semantic video indexing, and we used TwelveLabs' Pegasus Marengo to turn 45-minute lectures or really any sort of long form content, lectures or videos into around a few short reels automatically in real time. So essentially, here's the main disconnect is that short form content has kind of completely rewired how, our generation, Gen Z, Gen Alpha, consumes information, right? Where everyone wants stuff that's like quick and like punchy and like very engaging. So then you open Canvas, or whatever in whatever website your school may use for recording lectures or recorded lectures and such. And there's a 50-minute lecture video, and this drop off is brutal. From like research, students skip through it, miss the key concepts, and retain almost nothing. After 10 minutes, the retention drops from 100% to like 30%. But the problem isn't really the lazy students, it's more so the format, because nobody really has time for 45 minutes or an hour. Everyone only wants to, learn via 30-second content, and our multiple reels, such as maybe 5 or 6, 7 30-second reels, teach you the same material.
Yeah, and that's exactly what we explored throughout Tether. We wanted to challenge the idea if AI could take this 30 to 60-minute video and turn it into 5 to 8 short reels with fresh narration, relevant visuals, and burdened subtitles. Without any human editor, we wanted our whole Tether to create from the time it gets that video to the time it makes those reels without any human interaction, so completely automated. And as you can see, we use TwelveLabs using the Pegasus and Marengo model throughout the whole thing.
So now we'll sort of walk through how Tether actually works, kind of like the pipeline. First, the ingestion, the user pastes in a YouTube URL. We plan to expand this in the future, but right now our only main input is YouTube via YouTube link. Then we download the video using YouTube DLP and upload it to TwelveLabs. Then first Pegasus comes in and analyzes the full video and generates semantic chapters for each individual distinct part that it deems, distinct enough and necessary to categorize. And then Marengo takes a video for these most visually relevant moments. And then DeepGram converts the summaries into clean text-to-speech narration, and everything gets sort of stitched together. So essentially, TwelveLab powers the first two stages, which are the most important, and what really makes our entire app process possible.
Yeah, so to start off, let's move on to Pegasus, a bit more of a deeper dive. So it's not just about transcribing the audio that Pegasus does. A way we like to think about it is it actually does watch the video, just as a student would. It sees those diagrams, reads those on-screen text. It understands that one part of the video is explaining a whole different concept than 10 minutes later in the video. And this is very important because the whole point of this process is that we're not necessarily just making learning like quicker. We're also making sure that the students learn exactly what they need to learn. And just because it's going from like 60 minutes to like 6 minutes doesn't mean we can just like let go of some concepts. And that's exactly what Pegasus does. It makes sure that we still definitely stay on track to learn everything, and everything is still covered. And it does this by mainly looking at those visuals, understanding that this is like a different shift in topic from another topic, and understanding what the whole video is essentially teaching. And this is very key for any like mathematical concepts.
Now, this is sort of where things get interesting, especially with the implementation of Marengo. Now, Marengo really isn't doing like a simple keyword matching against like a transcript. It's doing cross-modal vector search. So every second of video gets encoded into a high-dimensional fingerprint at index time. So when Pegasus says that like a segment is about maybe battlefield tension in a war documentary video, Marengo searches that embedding space and returns to that exact timestamp from maybe 30-second timestamp from like 1430 to 15, with like confidence of 0.94. even if like nobody in the video directly, or like there was no verbal voice or diction in the video that actually said those exact words. Basically, it finds the right visual based on meaning and not just text, which is very interesting.
Yeah, essentially that's a quick wrap up of everything that's happening behind the scenes. A way we like to think about this is think about this whole process as like a part of a film crew. Pegasus is that editor, Marengo is a cinematographer, and DeepGram is a narrator, and FMPEG is like that post-production team. Everything coming together to turn that big lecture into those very small reels.
So here's what the output actually looks like. We fit in, for context, we're going to feed in a 30-minute statistics and probability lecture from YouTube, and we get back 6 reels in under 10 minutes. So each one is under 60 seconds, has, sorry, 6 reels back under a few seconds. And each one is under 60 seconds, has clean AI narration, relevant visuals pulled directly from the lecture, and auto-generated subtitles. You could drop these straight into a study app, a course platform, or just send them to a friend who missed class.
Oh, I think Bradley. Oh, okay, there.
Central limit summary video here, and I'm gonna do that because I need to brush up on that.
For some reason we cannot hear the audio from your YouTube.
Oh, I think it should be fine. Just a quick explanation of what's going on. We fed in a video about statistics and probability, and it's essentially just loading. I guess a way we can also answer one of the questions is the time it takes to analyze a 30-minute video lecture. From what we used Pegasus for that and Marengo, and I believe last time we checked for a big one would be like around 3 to 5-ish minutes for the whole process to run. But essentially, the statistics and probability one, we actually took a 10 to 15-minute clip of it and then turned it into short reels once again because at the time of the hackathon, we didn't have much time and we had to constantly iterate through this process. And the cost, honestly, I don't think it was that much. Did not look too much into the metrics, but I remember since we definitely toned it down a notch from that 60 minutes original plan to like 10 to 15, it did not cost that much. And then, yeah, Riley, if you want to fast forward a bit.
Sure. Yeah.
Our main focus was not to be like your generic
Basically,
like AI.
In this video, is just
every reel
talking
is
about,
tied to direct evidence
through the
moments
different
from the original
processes of
video,
how
and
we
we can see that right here.
are
Every single video
Here's,
right
like,
here
most-
is direct
most of, like, our
evidence to
front-end
the original video that we
implementation.
fed in, which was the central limit theorem that Bradley wanted to know.
And what's happening here is when you upload a video, you immediately hit our AI pipeline powered with 12Labs and DeepGram. Stage 1, Pegasus watches the entire video and asks, what are the key concepts a student needs to understand? It breaks the video into logical chunks and gives us a little summary and keywords for each topic. Stage 2, Marengo is essentially able to search inside our video by taking those keywords and says, find me the exact moments where the professor actually explains this and returns those timestamps. And stage 3, we use DeepGram to actually enrich these timestamps by using DeepGram's speech to text to see actually when the professor stops talking, and we decide to adjust our timestamps to that, so we prevent any awkward cutoffs and we ensure a smooth transition among clips. And to tie it all together, we use FFmpeg to stitch everything together with hooks, clips, animated captions, and smooth transitions, all for an enjoyable, easy educational experience.
So overall, unlike a lot of other tools that just summarize and don't give us exactly where they get the information from, Tether is built from that, and it's built for just learning. So we prioritize traceability, summarizes keywords and visuals that are all anchored to exact moments. That means faster studying, less rewatching, and more trust.
Whether it's a lecture, tutorial, or really any long form video, Tether gives you the power to learn by the way that's best for you.
We're Tether. Thank you.
Thank you. All right, great. Now to the next.
So yeah, I guess a way we challenge this problem, I know 12 Labs, I guess, is its own model, and we respect that, but we also respect the fact that, um, like combining several different industry level AI tools like Whisper from OpenAI, GPT for summarizing everything, and another one we realized was called Clip for more of the visuals. We wanted to know like why does 12 Labs allow us to necessarily accelerate over just using a component from each of these like industry level foundational models? And one way we were able to realize that is because 12 Labs is the only platform where both the understanding and the retrieval are genuinely like video native. We noticed that although you could definitely like turn in its transcript and put it in like a GPT and tell it to summarize to you, a better way to do that is once again what Pegasus does differently from anything in this whole process of using foundational models is that it actually understands what's going on in the video, like the visuals are actually saying. And once again, for any type of math lecture, any type of visually demanding lecture where we use a lot of flow charts, where we use a lot of equations, such video to text link is definitely important rather than just what the professor says. You put that into notes and then understand it. So yeah, that's one thing we definitely found about 12 Labs that foundational models do not do, which is great for 12 Labs.
So in terms of scaling, especially from our hackathon, right, we built this, at 24 hours at SB Hacks. First, our next steps are pretty clear. First, we plan on upgrading to Marengo 3.0 for more composed text image search, which makes the visual retrieval even more effective and sharper. And then second, LMS integration, sort of imagine it like using this as dropping reels or more short form content directly into Canvas or Blackboard to fully streamline the process of, first taking the long form video, turning it into reels, and then distributing it equally across, school networks and such. And then there's multilingual support because since Pegasus already kind of handles multilingual content natively, but we sort of need to still kind of manually distribute this across, all of our the entirety of, a project. But still our core sort of use or thesis case is already proven, and that is that 12 Labs, we use it to turn a massive long form video into many pieces of active and digestible content, being the short form reels. This is done fully automatically, and that's really what Tether's all about. So thank you.
Awesome. Thanks for preparing the detailed slide, walk through the quick demo. I think there's some of the point you mentioned is extremely relevant, and then kind of exactly talk about how we position our technology against other frontier models. That's like when you mentioned why 12 is video native, correct, compared to like Follow or the Gemini or like any other frontier labs. I think that is a very, very important point, which is like, those other models, they process frame by frame, right? And like, look at like a static frame from the video and extract or transcript all that versus like video. What makes it unique is actually the kind of the spatial temporal dimension, right? Like all the temporal motions in like activities and visual information, spaces, objects inside the content. So you cannot like apply traditional LLM to video. You kind of have to build a video native, right, for foundation model from scratch. So that's a great point that you brought up. Yeah, and then this use case is applied long to short. It's very, very popular. So great that you were able to use combination of both Pegasus and Marengo to efficiently turn long form footage into short form highlight reels, right? Not just education, but again, like this is very valuable for sports, right? If you think about like creating highlight reels from a game footage is relevant for entertainment, right? If you think about creating trailers from a TV show, like a TV show trailers from a raw footage, right? or like even news editing, which is like, getting a news footage from a raw accident scene, right? So again, it's a great like use cases for us to see. I know there's a couple of questions on the chat. So again, like Bradley and Madhav, you just want to go over them one by one. We still got about like 30 minutes left in the session, so let's just address all of them.
For sure.
Yeah, sure. Oh, I guess I could take the first one about the YouTube. Yeah, you're right. This was definitely one of our biggest pain points going into the competition. And originally we were gonna just do like they upload their own video URL or their own video files. But I guess the reason we pivoted towards YTTLP was because one, this was like the only way to actually, I guess, use like a YouTube link from online. But obviously because of that, we ran into multiple like slow downloads and a lot of blocks along that way. So a way going forward, and also to backtrack a bit, like a reason we use this for YTTLP and the reason we use YouTube in general was because for the demo in SB Hacks, we wanted it so that the judge can just come by, look at a video from YouTube, and then just like link it straight into Tether. We just wanted it for a merely visual purpose. But going forward, once again, having more options like the upload your own file, upload a Zoom lecture, or anything that makes the process a lot easier is definitely something that we have in the plan.
Yeah, and then what I guess to sort of briefly talk on what like Wajan mentioned, yeah, I think it would be actually really cool to create like the highlight reels with sort of I guess your own persona or sort of some like sort of distinctive factor or feature that really tells you, okay, these are my reels that I personally uploaded. Maybe we'll in the future we'll implement some feature that'll allow sort of the users to kind of contribute or sort of save. Well, we do have a saving feature already, like a library in our current implementation. However, maybe we'll utilize that more so practically by um, having, sort of maybe the model can kind of get a sense of who the user is, maybe the type of videos they watch, and then from there they can, from there they can personalize further and kind of sort of create your own persona, which is a pretty interesting idea. And then Suvasis, do we have a system prompt? Yes, actually, we have a system prompt in our sort of analyze video method for Pegasus. We prompt Pegasus with specific instructions, sort of like we start with pretty, to be honest, they're pretty, I think, fundamental, but like basic in the very structured way that we have like a title, which is, short, catchy title. I think max of 8 words-ish, and then summary is just a 2 to 3 sentence summary that, sounds just good spoken aloud verbally. And then we have keywords that we want to put in. Essentially, we're just asking to break the video into 5 to 8 segments, return structured JSON with titles, summaries optimized for, the text-to-speech narration, and then obviously, yeah, the keywords are for Marengo to, search and parse through so that, the two can sort of work in tandem together. We also, yeah, tell it to keep summaries, sort of like, yeah, how normal, I guess, as well as Pegasus can do it, but, as try to do it as normal humans, sort of say, would speak, kind of keep them conversational so they sound natural when spoken aloud.
Yeah, so I think Bradley was able to cover both of those last 2 points with that. I guess answer. Is there any other questions?
Oh, yeah, one more from Wajid. So, yeah, the lecture discussed a topic like polynomial distribution 5 times in a single video. How would we return that result set? So I believe currently how our model sort of like processes, I believe in this case it would just be repetition of like content from our sort of like I guess a statistics video, we did have a lot of same topics pop up, sort of like, regression or just, like the word of, linear regression, like pop up a bunch of times and stuff like that. So sort of what our model does in that case, we will definitely would recognize, not just like the word itself, but the topic is just being repeatedly called upon. So not only would it incentivize it to, make it more concise, but obviously that kind of points to the model, or that kind of directly shows that, okay, the model should be like, thinking, obviously this is probably taking into account, whatever the video title may be, as well as the context. But okay, obviously this is a very important topic, or one of the main features of the video that was given to me. I'm going to make this a main chapter or a main topic. Maybe I make this like one separate video by itself. And yeah, that's, I guess, essentially what it would do. Number one, make it concise. Obviously, it's not going to bring it up all 5 times, at least not in the reels themselves. It may reference or index the 5 different, timestamps of each reference, but in the end, it would only have, one reel to summarize it. And then obviously, with the summary being said, it would take up a lot of the summary, because it was such a heavily restated topic in the video in the first place. Do we plan to connect multiple videos? I think yes, definitely in the future, or in the long term, we will think about doing this, sort of back to what Madhav was saying with the how we handle like the YTLP. We obviously ran this sort of locally at first, because we had a struggle of like, just like figuring out, okay, how should we have our input sorry, how should we have our input structure be? But right, we were thinking of, adding further support for, um, in the future, having MP4 uploads as well. Maybe we'll look at services like proxy pools. But for now, I think in terms of multiple videos, we could add, right, for our current, YouTube link upload. How that might work is that we might try to first test for add a new feature, like maybe compatibility of the 2 videos, right? Obviously we want to we probably infer that the user would realistically, they would put in 2 commonly associated videos, like maybe one is just like lecture 1 and then lecture 2 from a class, not like some historical documentary and then some video game documentary. So that's like the first thing I would think we would be probably implementing. Sorry. And then right from there, it's just a matter of combining the 2 in terms of summary and right, parsing with Marengo.
Yeah. And just for context, like this problem of multi-video highlight reels is also like a big challenge, that we encounter. So especially like for like let's say everything about TV shows, for example, our customer in like the media industry, right? Everything about like TV show, micro drama, now the task is about like, okay, let's say, I can give you one example. So Love Island, right? The TV show, that is one customer that we're working with. So, they have like multiple episodes, right, in a season. And the task here had like, create a highlight reels, right, that only focus on one character throughout the entire season 1, but like 6 episodes. So now you have to like actually retrieve across multiple episodes, right? The best moment, but you need to like sequence it in a way that like the final highlight reel tell the good story, right? You cannot just like cut it from a random spot, right? In order, like how do you sequence the order of the clips being returned from Marengo so that it can create the best highlight reel. So I think that is kind of the next phase that we're exploring right now. We actually will have a new API endpoint that focus more on like it's like a video agent reasoning system. should be available like in April, where it can look at multi-view, multi-corpus video footage and those like content organization. You can prompt the API to like, this is the kind of sequence that I want, and it will automatically like go retrieve the footage and like return the kind of the sequence that that you desire, right? Obviously, this kind of basically solve the problem that you were tackling with the long short form highlight reels, but it's also applicable for many other domains as well. Think about like security, right? When you have to turn long footage into like short concrete insights that is relevant for the officer. Think about yeah, news editing that I mentioned already, like very long footage when you want to turn it into concise bite-sized segments that would be relevant for your TV news station. So it's all the same problem, by given massive amount of corpus level of video, how you can like extract the combination and the best like sequence highlight that that we want, right, from the end user. So yeah, like if you interested in checking it out, and definitely like stay up to date with our community, and that should be released publicly available at some point in April.
Sure. Sounds great. Thank you.
Yeah. I think that's all the question that we addressed. So yeah, thanks again, Aidan and Omar, as well as Bradley and Madhav for preparing. Well, first of all, for building with TwelveLabs during the hackathon, and also for kind of preparing your slide and doing the lab demo during our session today. So recording the webinar should be available at some point next week on YouTube. So be sure to like ping you guys when that become available. And yeah, again, for the attendees, we have this session on a weekly basis. So next month there will be like very similar hackathon projects from various events that we've done over the past couple of months. So yeah, if you found this informative and interesting, we'd love to see you again for next week. All right. Cheers, everyone. Enjoy the rest of your Friday.